the purpose of this video, we are going to talk about the same syntax every researcher will need before you'll be able to perform structural equation modeling. Unlike any other softwares like Israel M+, Smart PLS, and AMOS, these softwares provide you a very interactive graphical field where you can build your model just using diagrams, but you need to pay for them. They require license before you can use them. So if you happen to be in an institution or school where your school subscribes to such softwares, it's easy for you. But somebody who is a graduate or someone who is outside school or your institution does not provide access to these softwares, it means that you will not be able to use them. So for the purpose of this video, we are going to talk about Jamovi, a popularly known open source SEM software we can use. So it's a software when you want, just enter Google and type Jamovi download, and you can access its website and download it. You can download for your Mac, your Windows, or any other software you are using, PC you are using. So before you can do that, in this software, it allows you to build your SEM model using an interactive interface. However, you can also use the other way, which is the syntax. And the syntax, this software also uses what we call the Lavaan R package for the SEM. So you need a few syntax or equations to master before you can start. One thing I like about the syntax is that it allows you to model your data so easily. It also allows you to explore, in fact, probe more into finding the direct, indirect, and even total effect of the relationship between so many variables. You are able to do it on your own, unlike the software restricting you from doing that. So let's talk about just some few three syntax codes you need. So the first one is this. So putting in this syntax helps you to define latent variables in measurement models. Specifically, this particular syntax indicates that a latent variable is being measured by one or more observed indicators. So let's say, for instance, I want to measure job satisfaction. So I can put something like representing job satisfaction by job sat. Since I know that I'm providing, let's say, 3 questions for my respondents to rate their level of agreement with on a 5-point Likert scale from strongly disagree to strongly agree, which is 1 to 5, so that I'll be able to find out whether they have a job satisfaction, which is either high or low. I put in the syntax. You can decide to use spacing, or you can put them together, that doesn't matter. So I can do it this way, and let's say I have 3 questions for my respondents to provide their answers or their responses. So let's represent them by item 1. So I'll just say item 1. Since they are all collectively measuring job satisfaction, I'll just say item 1 plus item 2 plus item 3. So when I issue in this syntax, I get a first order CFA with arrows drawing from job satisfaction to the items, and this allows me to be able to check my factor loadings and model fit indices. It also allows me through this process to check the construct validity and reliability, whether discriminant validity or convergent validity, whether composite reliability or any other thing you are going to measure. So let's talk about the second symbol. This symbol, which you can find on your keyboard, is used to specify regression relationships or direct effects between variables. This operator signifies that one variable is predicted by another. So for example, let's say I want to find out whether work engagement influences job satisfaction. So in CFA, we do not provide spacing in between 2 words. You put them together or you can abbreviate them. So let's say work engagement. I can just say work engage. I can decide to use underscore, or I can do this work engagement, but that looks very long, so I'll just work engage. So influences work performance, or let's say job satisfaction. So work engagement positively influences. So I just want to find the relationship whether work engagement influences job satisfaction or not. So I'll just represent it by job sat. But you should bear in mind, in structural equation modeling or in R, the dependent is always, or the endogenous variable is always at the left, whilst the exogenous is always at the right. So the appropriate way to do it is to put it this way: job sat with the symbol, then work engage. So you delete this. So trying to find out the relationship between variables where you have the dependent and independent variable. The dependent variable, which is the endogenous variable, is always at the left side, whilst the exogenous, which is the same as the independent variable, is always at the right. So now, whilst you are modeling, you are trying to find out whether there is a relationship or there is a correlation between variables. With this, in correlation, it doesn't matter where you put your dependent and independent. Since correlation doesn't determine any dependent or independent, you just want to find whether an increase in one result into the other or that. But still, you can still use your dependent independent based on the kind of hypothesis you are trying to answer. So let's say I put up a hypothesis that work engagement correlates with job satisfaction. With the second one, which is this, we're trying to say that work engagement predicts job satisfaction. But with the second, we want to say whether work engagement positively correlates with job satisfaction or it negatively correlates with job satisfaction. It's the same thing. We just put job sat, then we'll put the two symbols. You don't need to space it, or you can decide to space them. You can even put them this way. Then work engage. And that gives you a correlation. You also bear in mind that we also use that for covariances. Let's say during your first order CFA confirmatory factor analysis, you realize, or second order confirmatory factor analysis, you realize that your model fit indices were very high and you had no option. You want to use your model fit indices, the modification indices to correct your model. So it means that you want to covary error terms within a particular construct so that you can bring your model fit measures down. So let's say our error time, we have E1 or E1, E1, E2, E3, E representing error terms. So, and they all fall under the construct job satisfaction. So you want to covary, you check your modification index and realize that if you covary error term 1 and error term 3 under job satisfaction, it reduces the values by 41.06. So once you build your model with all these syntax, you can go ahead to covary them. So you can also use the same syntax or operator to cover your error terms. You will see that in the practical aspect of this video. So let's say I want to covary error term 1 and error term 3. I simply put E1 this and E3. So let's say throughout the modification indices running, I found out that if you covary error 1 and error 3, it reduces. And there's another suggestion where I can covary error 1 and error 2. So I don't need to repeat the same process where I'll say error 1, error 2. I can simply put plus, then I'll say error 2, and be able to get